Hi grade 10s, today I'm going to make my second lesson on trigonometry for you. You can see on Google Classroom that I posted yesterday's video right here, and once I finish making this video, I will add it right underneath it and you'll be able to find this video. Okay, so I want to show you what I'm going to do today. I'm going to go to our Google Classroom. I'm going to go to classwork. I'm going to click on our trigonometry project. And yesterday we looked at page 1 and page number 2. Today what we're going to do is we are going to look at page 3 and figure out exactly what this means inside of the red box. What I've done on my table is I've drawn 3 triangles. And these 3 triangles are interesting because they are all very similar. Each of them have an angle of 28 degrees, and they each have a 90-degree angle. So they are certainly very similar triangles. What I've done is I've measured the sides, and I want to show you some interesting things today. But before I start, I want us to use what we learned yesterday to label our triangles. So remember, first we do the hypotenuse. So the hypotenuse is always going to be the side that's the longest, the side that's diagonal, the side that would be the C in Pythagorean theorem, and the side that's opposite from the 90 degree. So here's my 90 degree. This right here is my hypotenuse. Right here, this is my hypotenuse. And this is my hypotenuse. And yesterday, I know some of you have watched that video. It's a little silly. I want you to imagine that there is a little girl at the reference angle wearing a dress because the angle kind of looks like a dress. Here are her pigtails. She's forgetting to wear her diapers, so she pees her pants. And right here, this would be the puddle or the O for opposite. And the same thing for the other triangles. So we know my H and my O. That means the last one is A. Now, that is the first very important step. If you can't figure out the difference between O and A, then you want to send me an email. You want to send me an Instagram message so we can talk about that. Because if you can label the O and the A, then the rest of this video is really easy. So what I want to do is I want to make 3 fractions. For each of these triangles, I want to make the fraction O divided by A. Opposite divided by adjacent. Opposite divided by adjacent. Now let's look at the biggest triangle. We can see that our opposite side is 13 and our adjacent is 24.5. For our middle triangle, our opposite is 8.5, our adjacent is 16. For our smallest triangle, our opposite is 4.8, and our adjacent is 9. And we're going to change all of these fractions into decimals so that we can compare them. So we have 13 divided by 24.5, and we'll keep only 2 decimals. Gives me 0.53. And then I'm going to do the next one, 8.5 divided by 16. Oh, that also gives me a 0.53. And then the last one, 4.8 divided by 9, gives me 0.53. They are all exactly the same. And the reason the fractions are exactly the same is because the triangles all have a reference angle of 28. Now, if you look at the worksheet that I gave you in the booklet, there is a box around this. It says this, tan of angle A is equal to opposite over adjacent. So we have opposite over adjacent. A, this A right here just means the reference angle. Okay, so let's see. Our reference angle is 28. So if I did tan of 28. Opposite over adjacent says it should be 0.53. Let's try my calculator and let's check. If I go on my calculator, I find that tan button, tan of 28. Oh, on this calculator, you have to press 28 and then the tan. Oh, look, I do get 0.53. So what I want you to understand is when you see these buttons, tan, cosine, today we're just focusing on tan, is tan tells you what the decimal is when you take the O side divided by the A side. And what I want to do is I want to label them H, O, and A. Okay, so they all have 90-degree angles in this corner. That's the only reason we can do trigonometry, because I've drawn them as right angle triangles. So that means the H in all of them is this side right here. If we think about the girl and the puddle, the opposite angle is going to be over here for each of them. This is my opposite, my opposite, my opposite, my opposite, and my opposite, leaving this side on the bottom to be the A. And you'll notice that the A in each of them is the same. It's always 4 because the distance from the middle to the outside is always the same. On my protractor, it's 4. Okay, so now remember in that red box, it told us that to find the tan ratio or the tan fraction, I had to do O divided by A. So O divided by A means here I have 0.7 divided by 4. Here I have 1.5 divided by 4, 2.3 divided by 4, 3.4 divided by 4, and 4.7 divided by 4. That is my tan ratio. And for this one, it's the tan ratio for 10 degrees. Here, it's the tan ratio for 20 degrees. Here, it's the tan ratio for 30 degrees. Here, it's the tan ratio for 40 degrees. And here, it's the tan ratio for 50 degrees. Now, trigonometry tells me that when I do 0.7 divided by 4, it should be the same thing as when on the calculator I do tan 10. And 1.5 divided by 4 should be the same thing as tan 20. And 2.3 divided by 4 should be the same thing as when I do tan 30. 3.4 divided by 4 should be the same thing as when I do tan 40. And 4.7 divided by 4 should be the same as tan 50. I will show you the first one, and then I want you to push pause on this video, and I would like you to check the others. I know that they're the same, but I want you to show yourself that they're the same. Okay, so I'm going to go 0.7 divided by 4, O divided by A. That gives me 0.175. Okay, now, hopefully tan 10 is something really similar to that. The only reason it would not be exact is because I'm using this ruler here to measure, and you can see that it's really tough to actually measure appropriately with a ruler that is so worn down. Okay, so now I'm going to go 10, and I get 0.176. So this one was 0.175, this one's 0.176. That's basically the same. If I could have measured this more accurately, like if this would have been 0.72, I would have gotten the exact answer. So yes, the tan ratio, the fraction, and tan 10 on the calculator give us the exact same answer. Now, I want you to press pause, and I would like you to try. What we've just done today is we finished page 3, 4, 5, and now we are doing the work on page 6 in that table. We're calculating tan of 10, tan of 20, tan of 30, tan of 40, all the way up to tan of 80. So if you complete that chart today and you understand today's video, then that's fantastic, and you're done for today, and please sign in tomorrow for another short video.